Welcome to the Mentored Engineer. In our last video, we looked at sizing the geometry for our log splitter jib. We looked at different lengths and strokes of cylinders, as well as different pivoting positions to give us the articulation that we desired. In this one, we're going to lay out how to calculate the forces at the reactions here. We're going to look at the pivot, and we're going to calculate the force of the cylinder. Once we know those things, we can calculate a lot of other stuff. Now if we look at our drawing here, we have our vertical tube with the jib coming off of it, pivoting at the top. Then we have our cylinder pushing up and holding that in position. We have our load W and our length L, as well as two angles, the jib to go to ground and the cylinder to the jib. And then lastly, we have our moment arm of the cylinder, which we got from SolidWorks, and we saw how cool that was. So now what we're going to do is we're going to look at calculating the statics of this. And the first thing we need to do is set up our coordinate system. Now here you notice that I chose it to be in line with the jib. And that's really for mathematical simplification. And as we start articulating this thing, that X direction always stands perpendicular to the, or parallel with the jib center line. Alright, if we put it here, it's going to change for every position, just going to make our math a little bit harder and complicated. Alright, so what we're going to do is we're going to put our forces on here. So the first one we have is the force of the cylinder, and then we're going to have force A and force B. Alright, and they're just going to go up there in line with those ones. Alright, so let's start writing some equations. Let's start summing the forces in the X. And that's going to be equal to 0 because this is a statics problem. Alright, so the first thing, we obviously have force A. And then we're going to have a slight negative component here of the force of the cylinder. And that's going to be times the sine of delta. Now, a hidden one is this is actually not in line here. If you remember from geometry, it's perpendicular, so that's actually theta there again. So that's going to be W sine theta. All right. So, and when we go here to sum the forces in the Y, it's going to equal 0. This time, we've got B going up. We've got the force of the cylinder times the cosine of delta, once again minus W and the cosine of theta. Alright, so those are two forces. Now you may have noticed here that this is a lever. I've got a load down, I've got a force up, and then I'm pivoting here. Now you can imagine that just to keep this in a static condition, if I'm going down here and I'm going up there, this one's actually going to have to be going down. So when we calculate B here, we're going to expect it to be a negative number. So if it doesn't come out negative, that should be a red flag to us. So finally, we're going to sum the moments at the origin here, O, and that is going to be equal to, well, let's get a direction here first. So I've got my X and Y, and my fingers wrap around this way, so right-hand rule tells me we're going to sum the moments that way about the pivot. Alright, so we've got force of the cylinder and the Y going that way. And that's going to be times the moment arm minus W. W times the length of the jib times the cosine of the angle. Alright, so there's our forces. You could see kind of from this last equation why I could say, hey, this is the cylinder force so easily. This is a known, this would be a known, that would be a known, and that's a known. All right. So that's the only unknown in this equation. So this is the only equation that specifies what that cylinder force would be. All the other ones are dependent on this one to get A and B respectively. Alright, so the last thing we're going to do is we're going to sum together A and B using Pythagorean theorem, or as I like to call it, Rasmussen's law, because I proved it, so I named it after myself. We're just going to use a squared plus b squared equals c squared and get our resultant force here, and then we'll have everything we need. Thank you for watching The Mentored Engineer. I hope this was helpful to you. I hope you learned something, and I hope you can use it in the future. Thank you for watching.